Okay. Notes and learning goals for limits. Part 5, it says learn technique 1, plug A into F. If it works, you're done. All right, so example of that, let's say limit as x approaches 2 of x squared. Okay, so your first strategy is going to always be just to plug that number in. Is that a defined number? Yes, it is. We know what 4 is. So we're done. That's the limit. Let's look at a more complex one. Limit as x approaches 2 x squared minus 3x plus 2. Oops. Let's not approach 2. Let's look at it as x approaches 1. As x approaches 1 there. All right, throw it in and see what happens. So we're looking at the limit as x approaches 1. This thing. Throw the 1 in, see what you get. All right, we get 1 squared, 3 times 1 plus 2, 1 minus 2. Let's see, that's going to be a negative 3 plus 3. That's a 0 over negative 1. Is that a defined number? Yes, it is. 0 over a number defined is a 0. Okay, so that's our limit, 0. Okay. All right, so that's the first technique on part 5, technique 1, plug A into F. If you get a defined number, then you're good, you're done, that's it. Okay, let me just talk about some defined numbers. Okay, so if you get a number that you know, a number, good. That's a number is defined. 0 over a number other than 0. So 0 over a number that's not 0 is defined. It's 0. Okay. Some undefined numbers. Undefined numbers. Number over 0. Or 0 over 0. These are undefined. Okay, so if you throw the number into the function, like here we throw 2 into x squared, we got 4. Here we threw 1 into there, we got 0 over negative 1, which is 0, right? Negative 1 is a number that's not 0, that equals 0. Okay, 0 over 0 does not equal 0. All right, so if you throw the number in there, you get a defined number, you're done. You get an undefined number, you got to do something else. Okay, so bullet point 2. Bullet point 2 is this situation. You get the undefined number, which is a number over 0. This means you found an asymptote. So the limit as x approaches 0 of 1 over x, first things first, you throw the number in, you get 1 over 0. That means you found an asymptote. Okay, what's an asymptote? All right, so looking at the graph of 1 over x, something like this. You can see that, okay, so first thing is this doesn't make any sense. This just means you got an asymptote. Who knows what that is? Okay. So here's the graph of 1 over x. F of x equals 1 over x. Okay, you can see that as x approaches 0 from the right, we get large without bound, positive infinity. You can see that as x approaches 0 from the left, we get small without bound, negative infinity. So they don't agree, so this guy does not exist. Okay. Another example, 1 over x squared. First things first, throw the 0 in there. That means we found another asymptote, okay? All right, so first of all, undefined numbers. So let's look at the graph. 1 over x squared, looks like this. As x approaches 0 from the right, we approach positive infinity. As x approaches 0 from the left, we approach positive infinity, right? So here, our answer is infinity. Now, infinity is not a number, right? This just means that as x approaches 0, 1 over x squared gets large without bound. It's large. Infinity is big, right? All right, so there we go. Okay, last situation. Last situation is you get 0 over 0. Here you have to use a different technique. And that different technique is given in part 6. Okay, so let's look at a limit as x approaches 2, x squared minus 3x plus 2 over x minus 2. All right, so first things first, your first step is just to throw the 2 in there and see what you get. In this case, you're going to get 0 over 0. I factored this in the previous video and showed you why it's 0 over 0. But you could just compute it, right? You've got 4 plus 2 is 6, minus 6, that's 0, 2 minus 2 is 0, so 0 over 0. Okay, when you get this 0 over 0, what that tells you have to do is use a table and investigate the limit. Okay, I'm calling this thing f of x. So f of x here, I mean this function here. So we have 1.9, 1.99, 1.999, 2, 2.001, 2.01, 2.1. So if you plug 1.9 into our function, just into our function here, let's say this is f of x. So you put 1.9 in there, you get this number. Okay. 0.99, 0.999. Okay, Now, as we said before, this is undefined, right? So this is, you get 0 over 0, which is undefined. We just don't know what 0 divided by 0 should be. So that's why we call it undefined. Okay, but look what's happening, right? As x approaches 2, as x narrows in on 2, there is a specific number that f of x narrows in on. It narrows in on 1, right? You can see that if we did 1.9999 four nines, we'd have 0.9999, right? And if we had 2.0001, we'd have 1.0001. So as x approaches 2, f of x narrows in on 1. It gets close as we want to 1. So here we would say